SwayamPrabha. Digital India. Educated India.
Dear students, in the preceding lecture, I introduced the concept of efficiency and optimality and also explained the three types of efficiencies: technical efficiency, allocative efficiency and economic efficiencies. I also introduced two types of efficiencies, one in consumption or exchange and other in production. In this lecture, you will study about efficiency in consumption or exchange. I will explain you first, taking two conventional product, how efficiency and Pareto optimality is achieved using two conventional products which we generally consume, and later on I will introduce the same things in case of bad products, that is actually environmental bad products like garbage, and then finally I will sum up the topic. Let me now explain efficiency in exchange. First I will take two good products, and after that we will introduce the same concept by taking one good product and one bad product. To explain the inefficiency in exchange, let us consider two persons, say X and Y, who have some quantity of two goods, say cheese and wine, and wish to enter into exchange. They wanted to trade. First we can draw in difference curves for these two products for both the consumer X and Y, and we can assume that X is having 1 kg of cheese but no wine, and Y is having a bottle of wine but no cheese, and both would prefer some quantity of both in order to maximize their utility or satisfaction, and their welfare will increase if they enter in the trade. We can enter in a barter system, and if prices of the product are known, then price system can also be introduced. So, in this case Edgeworth box is a useful graphic way of representing the exchange of two commodities between the two individuals. But before discussing the Edgeworth box, let me first take the X preference for two products, cheese and wine, and here we take indifference curve U0 and U1 for X person. Similarly, you can also draw U0, U1 for Y person, and the utility or satisfaction is maximized for X person at the point where the slope of the indifference curve is tangent to the price ratio of the two product cheese and wine. So, AB here is the price ratio or price line which can be constructed depending upon how much is the market price of cheese and wine and how much is the money going to be spent by the consumer on these two products. So, any point on AB line is called feasible solution. So, under the given budget constraints, the consumer X can purchase any bundle of cheese and wine if it is on the AB line or below the AB line in the triangle OAB. So, any point lying on AB or below the AB in the triangle OAB are called feasible solution. Like M is feasible, but not efficient, because here the entire budget is not utilized to consume at point M. AB, any point on AB is feasible, but out of the feasible solution there would be only one optimum solution, and optimum solution will be at the point where the MRS, marginal rate of substitution between the two products cheese and wine, that is called actually the slope of indifference curve. The slope of indifference curve is equal to the slope of the budget line AB. So, E is the optimum point, P is not the optimum point, although P and E provide the same level of satisfaction, but under the given budget constraint P is not reachable, P cannot be achieved. Similarly, N provide higher level of utility to the consumer, but N is not obtainable, not reachable, because to reach at N more funds, more budget is required, and that is why it is outside the budget constraint or budget line of the consumers. So, this is the indifference curve of X person. Similarly, you can also draw the indifference curve and optimum level of utility taking cheese and wine for Y person, and once you get this, then you can superimpose the indifference curves of both X person and Y person, and then you can draw the Edgeworth box. So, this Edgeworth box is shown in this graph, and here on horizontal axis wine is taken and vertical axis cheese is measured or cheese is taken, and X person's utility is taken from the horizontal axis below, and Y persons on the horizontal axis above. And here we draw AB, that is the indifference curve for X person. Similarly, from upper side you can draw the indifference curve AC for Y person, and both curves are convex to the origin, because you have to read the AB, that is the indifference curve for X, from below, and then indifference curve of Y person from the upper side, and both are convex to the origin. Now, if you have a map of indifference curves that are shown in the graph, and these indifference curves are tangent to each other. So, Y's indifference curve is tangent to X indifference curve. So, if you draw a line intersecting all these tangent points, then you will get a contract curve, and contract curve is also known as Pareto optimal or Pareto frontier. So, Pareto frontier is here MN. So, MN is the Pareto frontier or contract curve, which is drawn by intersecting all the tangent points of the indifference curves of X and Y, when you have a map of indifference curve of X and Y. And these two bigger indifference curve AC and AB shows that there is a larger area where the utility of both the persons, if they exchange each other, can be maximized. For example, if the consumer X moves from G towards E, then it will be called Pareto improvement, because here the utility of X is increased without reducing the utility of Y. Similarly, when Y move from E2 towards G, then it is again the Pareto improvement, because here the utility or welfare of consumer Y is increased without reducing the welfare of X person. So, if these two persons exchange each other the quantity of cheese and wine, then they will reach at the higher level of satisfaction, and that is shown in the middle of these two bigger indifference curve, where there is a tangent point of these two indifference curve, and optimization or Pareto optimality will occur on all the indifference curves on the contact curve or Pareto frontier, but actual exchange will be metallized only in the area A, B, C. So, any point in the region A, B, C at which the indifference curve of X and Y are tangent to one another lies on the Pareto frontier, and they are called contact curve. So, efficiency requires here that marginal rate of substitution between wine and cheese should be same for both the person, and marginal rate of substitution for cheese and wine are same for both the persons at the point where the slope of both the indifference curve tangent to each other. But that is pure if we want to introduce market, then we should know how much is the price of these two products. So, let us now introduce market and then see the exchange of cheese and wine between the two person X and Y. Let CO and WO be the initial endowment of cheese and wine respectively. Initial endowment means they are having the quantity of cheese and W at the initial level. X is having this quantity. Similarly, you can also see the Y's initial endowment. Let X star, C star and W star be the quantity of the two goods X eventually end up after the trade. So, after the exchange, the C star and W star are the quantity which will be received by X. Let prices of two commodity be PC is the price of 1 unit of cheese, PW is price of 1 unit of wine, and we can now make X budget balancing equation by taking the value of the two products which are having by X, for example, like P, if you multiply the initial quantity of cheese available to X with the market price, you will get the value of cheese. So, PC C0 plus PW W0 is the total value of cheese and wine available to the X, and that will be actually equal to how much after the trade the consumer X is having, that is PS price of cheese multiplied by quantity of cheese, that is C star plus PW capital W star, since the amount is not going anywhere, the exchange is between the two parties. So, this equation can be written in terms of C star on the left hand side and W on the right hand side. Then we can convert this equation in terms of the quantity of cheese that is actually received by X person after trade, that is C star equal to bracket C0 plus that is the PW divided by C0 multiplied by W0, and that is actually the intercept of the line, and minus PW divided by PC, that is the slope of the or price ratio of the two products, slope of the price line multiplied by quantity of wine actually received by the consumer X after the trade. So, this equation describes a linear line with slope minus Pw divided by Pc. So, slope of the line is negative, indicating that there is a trade off between the two. Defining the budget constraints, if like combination of C star and W star are affordable on the budget line, as I already told you that any point on the budget line is achievable under the given budget constraint. So, in this Edgeworth box everything is same, which we have already discussed, only now we have introduced the budget line which passes through the initial factor endowment, and initial factor endowment are at point A, where initial factor endowments are C0, W0 and they are labeled at point A. There are many allocations between the contract curve Mn that are Pareto optimal, as I already told you. So, you can take any point on this Mn line, that is contract curve or Pareto frontier, they are called optimum point, but all optimum point cannot be materialized, that depend upon how much is the budget of the consumers or how much actual quantity of the two products are consumed by the two consumers. So, if initial endowment are at point A is different, a different allocation will result. So, in fact, by changing the initial distribution of cheese and wine, any point on the contract curve can be obtained using the price system. So, here AD is the price line which is determined on the basis of how much the money is spent on the two products and how much is the price of cheese and wine, and this budget line is having negative slope, and this budget line is tangent to the indifference curve of both x and y, and therefore, three conditions are met here at point equilibrium point. First, the budget line is tangent to the indifference curve of x person. Second, the same budget line is tangent to the indifference curve of y person, and third, the slope or MRS, marginal rate of substitution between cheese and wine, is same for y and x person, or the slope of indifference curve is tangent of x person is tangent to the slope of indifference curve of y person. So, that is why it is called efficient combination. Now, so these things I think I already now if we take the same concept in environmental economics, instead of taking cheese and wine, we take one product that is good product and other the bad product. Say wine and garbage. If X person is having some bags of trash or garbage and also a bottle of wine, but Y is having nothing. So, can exchange take place or can trade take place between the two? The answer is yes. So, so in that case what you have to do is, first you have to draw the indifference curve of X person and indifference curve of Y person. In this case, since one is good product wine and other is the garbage bad product, so indifference curve shape would be different, unlike the conventional indifference curve which is convex to the origin and having negative slope. In this case, the indifference curve will have a positive slope or upward sloping, because if you want to keep the utility constant, if you are consuming one more quantity of good product, you have to reduce the or you have to consume more of the bad product in order to keep the utility constant. So, if more wine is consumed, more garbage will be consumed in order to keep the utility constant. But here consumption of garbage does not mean the consumer is directly consuming the garbage. It means the consumer is taking the garbage and safely dispose of. This is the indifference curve of X. You can see the difference here. Indifference curve is not a conventional indifference curve, because on vertical axis we are taking garbage and on horizontal axis we are taking wine, and this U0 clearly indicate that if you wanted to consume more of wine, you have to consume more of garbage in order to keep the utility constant. So, this is actually the definition of indifference curve, that the given level of utility can be achieved by the consumer using the different combination of two products. So, given level of utility U0 can be achieved by the consumer using the different combination of garbage and wine. Now, what will be the optimum combination of garbage and wine? That depend upon how much is the price line. So, here price line or the factor price line or the budget line or price ratio of garbage and wine, they are shown in the form of AD line. So, AD line is tangent to the indifference curve U1, and at the point where this budget line is tangent to the slope of indifference curve, optimization will occur. So, forms this X preference curve U0 U1 clearly indicate that higher the indifference curve, higher will be the level of satisfaction, and here E1 is the optimum point where the consumer is consuming optimum quantity of garbage and wine. Similarly, you can also draw the indifference curve for Y person, and then you can superimpose these two, and then Edgeworth box can be drawn. But let me first draw the budget line, and then we take the budget line, and after that we can know the optimum combination. Just so, let us take garbage G0 and WG0 be the initial endowment of garbage and wine. Let G star and W star be the amount of garbage and wine end up with the X person after the trade. Budget balancing equation in the same manner can be done here. PG is the price of 1 unit of garbage, G0 is the quantity of garbage. So, if you multiply the quantity of garbage with price of garbage and try to understand that PG is negative, because garbage is a negative product, no one would like to purchase garbage unless price is paid by the person who is selling the garbage. So, PG is negative, but PW is a positive price and W0 is the quantity. So, the amount of money that the X is having in terms of value of the two products are PG WG plus PW W0, and that will be equal to the actual quantity of garbage remain with the X person after the trade, and actual quantity of wine remained with the X person after the trade, that is PG capital G star plus PW capital W star. So, now you can convert this equation in terms of W star, and that is exactly the same things here. PG divided by PW multiplied by G0 plus W0 is the intercept of the budget line, and minus PG divided by PW is the slope of the budget line, and since PG is negative, so negative multiplied by negative becomes positive. So, in this case the slope of the budget line is positive, while in case of cheese and wine the slope of the budget line was negative, and slope multiplied by the actual quantity of garbage that is materialized by the consumer after the trade. So, slope of this line is positive since price of garbage is negative. So, a quick check will see that the initial endowment capital G O capital W O satisfy the equation, which means that line passes through the initial endowments of garbage and wine available to the ex consumer. So, this is the Edgeworth box prepared in the same manner as we have prepared in case of wine and cheese. Only difference here is that these indifference curve are not convex to the origin and they are not having negative slope, they are having positive slope, because one product is good product and other product is bad product. So, the shape of Edgeworth box is different from the conventional shape of Edgeworth box. So, initial factor endowments are at point A and X persons indifference curve is AB, Y persons indifference curve is AC, and the area between A, B, C is actually the pie, which can be distributed between the two depending upon their bargaining power. So, if consumer X moves from G to E, then it is Pareto improvement, and if consumer Y moves from E towards G, then again it is Pareto improvement, but Pareto optimality will occur at the point where the slope of the indifference curve of Y is tangent to the slope of indifference curve of X, and both are tangent to the price line AD. So, this is the equilibrium level or market efficiency occurs at the point where the slope of the indifference curve of the two persons in case of garbage and wine are having the same slopes and their slope is equal to the slope of the price line. Let us now sum up. So, let me just tell you in brief what I had discussed in this lecture. First, I discuss the concept of efficiency. There are three forms of efficiency which I have discussed: technical efficiency, allocative efficiency and economic efficiency. Technical efficiency multiplied by allocative efficiency is equal to economic efficiency, and economic efficiency achieved at the point where the isoquant is tangent to the factor price line, and at this point all the three efficiencies will be equal to 1, and any point in case of isoquant above the isoquant will be termed as technically inefficient. Similarly, if any point is below the factor price line will also be termed as allocatively inefficient. If an economy actually operate on the Pareto frontier, you can see that economy is operating at the efficiency level, 100% efficiency level. And here I also introduce two types of inefficiency. One is inefficiency in exchange, which have been discussed in detail in this lecture, and inefficiency in production. Inefficiency in exchange means that the resources could be moved around among individual without making anyone worse off. So, if you can make at least one person worse off, if you want to make another person better off, then you can say Pareto optimality is achieved. Inefficiency in production can be discussed through production possibility frontier, and this will be taken in the next lecture. Thank you very much.